Hi, everyone, and welcome to Digital Double Shot episode number 2, a Geomagic Utility Solutions webcast where we share topics related to the natural gas industry. I'm Jason, and unfortunately, our friend Jim will not be joining us this morning. He's out sick, so we'll have to sail without him here, but he will be back for episode number 3, so don't you worry. This episode is brought to you by, of course, Geomagic Utility Solutions, providing digital solutions for utilities that enable efficient compliance, integrity, and asset management work processes. So today we're diving into a growing challenge in the utility sector. So that's managing data across multiple systems, and the real problem comes when these systems aren't properly synced, and one system gets updated, but the other doesn't, and this creates major alignment issues, leading to discrepancies and problems down the line. For utilities trying to solve these challenges, we're seeing folks who are, outputting spreadsheets, manually comparing these spreadsheets to identify these discrepancies. And this takes a lot of time. And the analysis capabilities when you're doing this type of method, it's very limited as well. So in the use case, we want to talk through how we can streamline this process for identifying and correcting missing data between multiple systems using a solution called geospatial analysis. And to help us unpack some of these issues around the use case and to explain the more streamlined approach, we've got a special guest today, Hannes Moser of Geomagic. And Hannes started his career at Geomagic as a technical consultant, software developer, and in addition to being our president and CEO, he's an executive to our parent company in Germany. So really great to have you on here, Hannes, and thank you for making the time.
Thanks, Jason. I'm excited to be here.
So Hannes, let's go ahead and we'll start from the top. What's causing some of these data issues today?
Yeah, so typically our customers, they're always facing that problem that they have several systems which are specialized for a particular use case and different departments using them. And then over time, differences between data grows because they're kind of rely on the same data or similar data. And then each system is collecting data over time. And then, over time, we have integration problems. So typically the systems are not that well integrated. They lack interfaces, corresponding interfaces. And then over time, inconsistencies and misalignments just grow.
Yep. And yeah, I'm seeing that a lot too. A couple of examples there would just be like even in the cathodic protection space, right, where you have these specialized systems that are designed to store all of the inspection data related to cathodic protection. But of course, some of that data has to flow into the GIS system. And oftentimes that's an issue, right? Because they're not properly synced, they don't have the integration capabilities. And then you have that compounding effect too, right? That of course, inspections don't stop, right? You have to keep up with compliance as well. So now it's just that snowballing effect there.
Exactly. So here we have one simple example. We have a GIS where CP data is stored and also an ERP system. And for instance, the GIS side, we have a test station ID, a map location, and install date, for instance. On the ERP side, we have a work order ID, install date, and GPS coordinates. And now the challenge is to kind of spot the differences between the two systems and also figure out which system has the correct data, right? And could be either case. In some cases, ERP system might have the better data for some of the data entries, and then on the GIS side, there might some other area, for instance, the data is more accurate, and then the it's challenging to figure out. So what's the truth? What's the data? What's the real data? The current data everybody should use.
Yep. And what I've been seeing as well in the utility space there, Hannes, is they're kicking out data into a spreadsheet from their GIS, and then they're kicking out data from their ERP system. And they're just manually taking a look and trying to figure out, hey, what's missing here, what needs to be updated. And oftentimes they're just using unique identifiers, but oftentimes the unique identifiers are missing or something along those lines. So it's not enough, right? So
Right.
so what's the solution there?
So we have made quite uh, yeah we quite a good experience with a tool called geospatial analysis, because it's really great at and identifying and correcting data differences.
Yeah, yeah. And I've seen this tool. We've used it quite a lot, and it does a really great job of combining disparate data, both spatially and non-spatially, for analysis purposes.
Right. So we have in this use case we mentioned before, um, we natively connected test station data in spreadsheets, GIS, and ERP systems. And with that, you can create so-called business-oriented models for analysis. And the good thing is that after you did that, you can then flexibly use these models to compare data regardless of the underlying data source.
Very good. And Hannes, you mentioned that term natively connecting data. So what does that mean exactly?
It means that you tap directly into the data, corresponding data source, without the need to migrate the data in a different data store, a different database. You simply directly connect to the data source, and you kind of don't see you. It's not important anymore whether it's an Excel spreadsheet or a GIS system or an Oracle database, whatever. It's all kind of hidden, and then you
Mhm.
have a direct access to the data. And if the data changes, then also this abstract model changes. So you always have a current view on your standing data, and you don't have any migration burdens or delay in the analysis you do to spot the differences.
Yeah, that's good. That's good. Yeah, it seems like, IT groups within utilities, they're always kind of bombarded with projects. So it sounds like using this solution wouldn't be a massive project for, a utility to take on, right?
Right.
So can we take a look at some examples based on the use case here, Hannes?
Sure. Yeah. So one with this example, so we compare CP test station data. So we have on the GIS side, we have GIS data and ERP data and corresponding IDs, install date, physical location, and then also on the ERP side, we have corresponding data on, and so we can apply a logic which tries to match IDs or tries also to match install dates, and also combined with the distance of the corresponding geometries. So even if the IDs don't match, you still might be able to figure out that two objects in the two databases should be the same because they're close together.
Nice,
And
nice.
this can
So,
be
yep.
implemented as logic.
Very good. So yeah, instead of just being able to combine, unique IDs and things like that, you can unlock comparisons geospatially, right, to really identify what's different, what's missing.
Right. And then once you did that, once you have that logic in place, then you can create all kinds of um, different views on that data, on these differences. For instance, a map um, can be easily created then because you have the geometries, you have the locations, and then you simply create a map from that. Yeah, that's one simple example. So in this map view, for instance, we have a red dot where there's a data difference spotted. So there's a lot of data here, which is the same, but the algorithm spotted 3 locations where there is a difference based on that logic I explained before. And this can also be displayed as a list. Then you have a list of differences to go through, which is quite handy if you really want to have a thorough look through all the differences and check them and see how to solve them, right? And yeah, that's also be possible to have a really detailed view on one difference. Then you can compare really each data entry and also have a visual representation of the difference. Like on the right-hand side, we
Hmm.
have the location in the ERP system, location in the GIS system, and then we can really see what the difference is live on one map.
Yeah, I really like this functionality, right? Because it gives you that additional capability to do the analysis and identify, you know, what data belongs to each other, right? Based on the logic that you set up within the system, right? So this one is flagging if that certain threshold is not met, right?
Right. The good thing is with the one of the key benefits I see with GSA is if you fix the problem, if you say, okay, ERP location is wrong and you fix the location and you do a refresh on that analysis, it's going to have immediate effect. You're going to see immediately if that already solved your problem or not, right? You're going to, because you have that live view on the data.
Hmm.
So you can then simply easily check directly whether your changes have the effect you wanted to have.
Very good. Very good. And just to unpack the use case and give you a summary, the GSA tool that we utilize, right? We were successfully able to integrate data from multiple sources very easily, very seamlessly. Remember that term that Hannes reviewed, connecting that data natively. So instead of manually comparing spreadsheets, we were able to import that data into GSA, leverage its advanced analysis tools to accelerate the process. And in this case, we were able to bring together data from the spreadsheets, the GIS, and the ERP system for that analysis. Um, with GSA, we were able to uh, utilize various ways to compare those data sets and identify missing data. And the great thing about GSA is it offered that flexibility to conduct, both spatial, non-spatial, and logical-based comparisons. So for this use case, the versatility really provided more analysis options for us to identify those gaps. So for instance, if we didn't have unique IDs, we can do some testing using the GPS coordinates, and that was really a game changer for us in this use case as well. And of course, the results provided clear insights into what systems are missing data and the highlighted areas that needed the alignment. And the results could be presented in a number of different ways, as Hannes mentioned, tables and maps. So that really made things easier and more clear for us to understand those results. And additionally, as far as notifying folks within the organization on what data needs to be updated, what data is missing, GSA really was able to provide those results quickly throughout the organization, and that really made things a lot easier for us as well. So um, that's it for now. We want to thank Hannes for joining us, and we appreciate all of you for connecting with us. And if you have any topics you'd like us to cover, let us know. And until next time, stay safe, and we'll talk to you soon.